How to get started with embedded C4 microcontrollers. Imagine turning a tiny chip into a smart device that controls your home appliances or robots. That's what embedded programming is all about. If you want to learn how to do this using embedded C language, you're in the right place. Let's walk through the steps to get you started on this exciting journey. First, you need to understand what a microcontroller is. Think of it as a small computer on a single chip. It has a processor, memory, and input-output ports to connect with sensors, motors, and other devices. Learning about different microcontroller families like the 8051 series, ARM Cortex-M, or AVR microcontrollers is a good first step. Each has its own features and tools, so pick one that suits your project needs and budget. Next, get familiar with the basics of embedded C language. Unlike regular C, embedded C has special features to directly access hardware. For example, you might need to manipulate specific bits in a register to turn on a LED or read a sensor. You should learn how to declare variables, write functions, and use control structures like if-else statements and loops within the limits of embedded systems. Remember, embedded systems often have limited memory and processing power, so writing efficient code is important. Now set up your development environment. You will need an embedded C compiler and an integrated development environment or IDE. Popular options include Keil 4 ARM microcontrollers, Atmel Studio 4 AVR microcontrollers, or the embedded GNU C Compiler, which works with many platforms. Installing these tools usually takes about 10 to 20 minutes. Once installed, you can write your first simple program, such as blinking and LED. This helps you understand how to control hardware through software. After that, learn how the microcontroller starts up and runs your code. Understand the program counter, reset process, and how interrupts work. Interrupts are special signals that tell the microcontroller to pause what it's doing and handle an urgent task, like reading a sensor or stopping a motor. Knowing how to use timers and interrupts is key for more advanced projects. Practice controlling hardware by writing programs that use special function registers. These registers are memory locations that control specific features of the microcontroller. For example, setting bits in a register can turn on a relay or send data through a communication protocol like UART or I2C. Bitwise operations are your friends here, allowing precise control over hardware. As you gain confidence, move on to more complex projects. Try using timers to generate delays or communicate with external devices. For example, you could make a temperature sensor send data to a display or control a motor based on sensor input. Each project will teach you more about how embedded C interacts with hardware. Throughout your learning, focus on understanding how code translates into hardware actions. This hardware-software interaction is the core of embedded systems. Keep experimenting with simple programs and gradually take on more challenging tasks. With patience and practice, you'll be able to develop your own embedded systems for a variety of electrical engineering applications like automation, robotics, or consumer electronics. Getting started with embedded C4 microcontrollers is about learning the basics of microcontroller architecture, mastering embedded C syntax, setting up your tools, and practicing with real hardware. Each step builds your skills and confidence. Soon, you'll be creating projects that make electronic devices smarter and more responsive.